Hey there everybody, this is Nick Losee and Caleb Unger. We're going to be going over some random number generators and showing a handful of the results here. So we set our multiplier equal to 5, our C value equal to 3, modulus is 16, and our initial value is 5. You can see the results of that plotted over to the right. So we ran this 32 times, generated 32 numbers, and we wrote some code in lines 13 through 18 which identifies the ratio of the number of values divided by the number of unique values in that array, which represents the number of repeats for that period. Since the runs is 32, which is twice the size of the modulus, we should see that there's 2 repeats. And that's what we see in the graph. So moving on to part B, we increase our initial value to 7 from 5 and run this again. You can see a slight variation in the graph to the right. For part C, what we did here is increased the multiplier value, and what you can see on the right is that there are approximately 7 repeats here, and it just significantly increased the number of repeats within these the same number of runs. Okay, so now moving on to part B of our problem. For part B, we're essentially plotting to see the quality of this multiplicative linear congruential generator. And we can see here the lattice of the generator can be investigated by plotting the overlapping pairs of data. So for the x-axis, we're representing setting the initial value to 5, and the y setting the initial value to 7. And you can see here that this probably does have some uniform distribution of random numbers. However, it may not be that great of quality of a random number generator, seeing as how you could cover. For part B, we're essentially plotting to see the quality of this multiplicative linear congruential generator. And we can see here the lattice of the generator can be investigated by plotting the overlapping pairs of data. So for the x-axis, we're representing setting the initial value to 5, and the y setting the initial value